Hello everyone. This is a quick follow-up regarding the sizes of the nickel strips. So I decided to make it a little bit clearer. I brought a caliper here. These are the ones I welded yesterday. I had these ones, these 0.15. Somebody asked me if these were 0.10. No, they are 0.15, and they came from battery packs. Battery packs can have from 0.10 to 0.15 depending on the quality. Some even have 0.30. This is a 0.30 millimeter positive contact. It's been soldered on, but if you check here where there is no solder, as you can see, it's 0.31. Yeah, there, 0.30. So this is the thickest one I have. I didn't try yet soldering welding on this because it's actually got a lot of solder on, you know. I tried to remove it, but this stuff, it really sprays. So I'm not too keen on getting hot solder sprayed all over my hands and equipment here. So I will try to find maybe some cleaner one. Maybe I can weld on this side. As you can see, this side is cleaner. And there are two very big welds here. This came from a rather large pack. It was bent 90 degrees here, and this was from the solder or negative side, I don't remember. This is the thickest one. This is a 0.10 strip which I cut off, I think another pack. Yeah, it's nearly, depending on where, there, it's 0.10. Okay, this is the thinnest one I have. It's 8 millimeter width, and these are 2.12. This is what I usually use. I usually use 0.12 nickel strips. These are more than enough for, you know, everyday normal use. If you just solder a series pack, it's great. This is instead of 5 millimeter with always 0.12 there width. This can be used also, but usually for lithium ion and better use 8 millimeter width. This is basically standard, and these are the ones that I used yesterday, which I then unstuck without, yeah, they're a little bit ruined, but again, these are 0.15. Okay, well, depending on there, these are 0.15. So yeah, these are, it welds these two, and so with the current setup, with this let's say Rhino 5050C discharge battery and the shorter cables here, as I showed yesterday. Put this away. It's pretty much enough, more than enough, to weld 0.15. Use this aluminum heatsink here and silicon heat compound here. So let's try and test this again. These are the 2.15. Oh wait, okay. Set the camera, okay. Try to find a flat spot where it's possible to weld, and because it's pretty ruined, unfortunately I don't have other 0.15 millimeter. Let's try here. I also have a foot switch, but I didn't connect it. Okay, this is with 5 milliseconds. 5 milliseconds, 0.15 with this setup is okay. Oh wait, I need to put auto. Okay. So that's one single weld. You can see the two small welds there. Also on the bottom. And as I said, if the surfaces are clean, I'm sorry, and the weld and the nickel strip is new, and you get a nice clean weld without a lot of sparking, that's actually better than what you see here, but these are really abused strips. This is what I was showing yesterday, just 2 welds. If you do 4, then I can't get them apart and reuse them because they will rip. But just to show you, if I lever it and get in, and maybe use, I didn't want to completely break it, you can get this apart, but you have to wiggle it very gently so that you crease the spot weld. Otherwise you will rip it. Here, see, it's already creasing because it's not giving away. But if you ever so gently rock it, you don't need a lot. There, you see? If you violently rip it like that, usually you will break it. Now, you can see pretty clearly the spot welds here and here. You see 1 and 2. These are 0.15 millimeter, 5 milliseconds. Maximum, I would suggest 7 milliseconds if you really want to, get the spot weld. But let me show you what happens with 5 millimeters. If you look carefully, you will see holes. You see the hole on the bottom? Okay, here. You see it? Yeah, it's very small, but that demonstrates that this was a genuine weld and it actually fused this material. The fact that it's thick gives you the ability to rock it ever so slightly, and it levers on the weld. If you start rocking it on the weld, of course it will crack. But as I said, you really have to get in and do this carefully. So what I do is then I recover the weld, I squash it back down and run some other tests. But by doing this, you insert these creases. It's not really perfect anymore for welding, but for tests it's fine. Anyhow, if you can weld this 0.15 to 0.15 as I did, you're fine. Again, remember also that the tips here have been filed off and they are slightly rounded. Don't know if you can see it. I'll try and zoom in. You see they're a little bit rounded. You can leave a slight point in the slight more, let's say, kind of flat surface, but the fact that they're round, when they come, they're flat and they're very sharp on the edges, a little bit like here. And that just gives you a little contact area. And that contact area, there will be a lot of current going through. And yes, okay, you will be able to probably weld with a lower current. But that's, how can I say, that's a sharp corner here. And it will kind of like cut into the material. If you have this, if you check the big spot welders, they will always have a slightly pointy, but it's slightly rounded. It's harder to weld, but when you do weld, because there's a little bit more surface area, but when you do weld, you get a very good weld. So that's what I'm trying to say. I mean, it will weld also with the original flat contacts, but as I said, I suggest just to file it ever so slightly or all around, and this way, when you're touching it this way or vertically or a little bit like this, it's a rounded surface, so basically the contact point will always be the same. If you have this flat spot welder with a flat surface and you are like this, you will have like this little circumference, and I don't know, it's not so precise. You will always have a corner. Instead, with a rounded surface, I don't know, I've always seen better results like that. And I remember also with the larger spot welders, we always had, it was pointy, but it was always round. It was never a sharp edge. So that's something that is also relatively important for the quality of the solder, of the weld. So these were the 2.15s. as I said, I can try maybe the back here. Okay, with a I can maybe try again with a 15. This is again the one that I just welded, just for curiosity. Let's see if I can maybe weld it like this. This is really thick, so I don't know. I'm not so sure it will weld properly because it's pretty thick, and yeah, I will try again with 0.5 just for the sake. So let's see. Okay. Let's see. By the way, even just after one weld, if you touch this, it's warm. So I don't know how much current is going through, but it's pretty much. Okay. So let's see. I don't know if you can see it. Yeah. Okay, I'll try to bend it this way. Okay, that's where the weld is, you see, exactly there. Now if I continue pulling with my hand, I will probably rip it. So my suggestion is always there. You see? It disconnected. There's just now one weld left. If you rock it back and forth, just like this, it will just detach without breaking anything. There. These welds were actually pretty good. A little bit weaker than on the other two surfaces, but in fact, if you see the welds, right? Those two little points there, as you can see, they are present. So I guess you can go up to 7, 8 here, and then you won't be able to remove these as easily as I'm doing. So that's more than enough for testing. It demonstrates that the energy going through is very high. And then again, you have the two holes. I don't know if you can see them. There's a slight perforation from before. Okay, well, as you can see, this is a 0.30. It's pretty thick. Now, welding this on a battery, that's another thing, because you have to go through this. So unfortunately, to make a proper weld, I don't know if I can try maybe with one of these batteries, just for the sake of it. But you see, unfortunately, it's not, I don't have a flat surface. I wasn't able to clean this one up. Maybe here. Maybe like this. But if it's not flat, remember, you have to have a good flat contact, because that's important. I mean, with these thick weld strips, you really need to press it down, else it won't be able to go through. If it's lifted, it will just short, but on the same strip, and it won't contact through. It has to have a good contact. So yeah, on this probably I need to press a little bit more. Hopefully try to get a good contact, but I don't think with 0.5 it will weld. Okay. As you see, it didn't spark. Luckily, there is a little point, but I think that if yeah, you see, it came off. It did start to weld, but to weld these on, and then you have the two, you can see like there is the contact point there. To weld this, you would have to go up pretty much. And this, did you see that this actually welded together with the strip? That's what I was talking about, because when you are playing around with these high energies and thicker materials, you need to increase the time and increase, of course, the energy. And if something goes wrong, you have your contacts that are stuck on. Luckily, this doesn't re-weld automatically, but if the FET's short, you really have to pull them off quickly, because, you know, this battery here is next to my face, and I'm not too, I'm not too keen on having it burst up in flames. So I don't know. I think I will never use, of course, 30.30 strips. It's like an overkill, but it could probably handle them in a more safer, protected environment with I don't know, gloves or something, and try to spot weld, maybe going up to 10. But this mini spot welder is really not designed for that kind of energy, so I would definitely not suggest trying it. This was just something that I had lying around and I was curious. 0.15 with 0.30 or whatever, it will weld because you're going through the 0.15, okay? But going through this, that's a whole different game. So as you can see, these kinds of welds, they're very big, and I was able to detach them using that technique. You rock it back and forth. If you bend it sharply, that's not good. You have to lift it up a little bit, lift the other side, and start rocking it. Maybe it takes some time, but you will disconnect it. Any weld will eventually you'll be able to remove it. Of course, if you have a very strong weld and the nickel strip is thin, yeah, it'll start breaking like here, and residues will be left on the battery. You see, and these are several tests. So, well, that was just a 0.30, just for curiosity. These were the 2.15s, which like this one here. This is also 0.15, which is welded on. These are just two. You see the two welds as I did them yesterday. It's pretty strong. You can bend it up and down, it won't budge. You really have to lift it up and down to, you know, disconnect it. Okay, so let's see what else. Okay, so the 2.15s, you have the 10, the thinnest, and that's, I don't know, it's pretty obvious. All the rest here, this is just a brand new strip. You can test it maybe on the other side. This is a 0.12. This is the typical, let's say the typical welding strip for these batteries. Again, I'm doing it on a flat surface, avoiding the other residue, other spot weld residues here, which won't make it contact weld. That's really important. And unfortunately, this usually sparks because the battery is dirty, and so it will tend to spit out stuff, as you see. And you can clearly see the welds. I press down and you see it's if you want to break this weld, you can, if I bend it up like this, I'll probably rip it. Instead, if you rock it back and forth, it's thin, but you have to be very careful. You can try to redetach it. I don't know. Okay, like this. But as you see, if I lift it, it's creasing. You see, you have to lift both ends and try to kind of like rock it like with a V. Yeah, you see, I lifted this side up too, and then you take it like this and try to rock it back and forth. That's the only way you can try to detach it without ripping it. You do this gently. Yeah, well, yeah, 0.12 is it's pretty strong. But if you do it gently, maybe with this, you will see that this is it's an incredible amount of force because you're bending both sides. You rock it back and forth. I think one is maybe, yeah, there, I managed to. Let's see. But as you can see, I mean, that's the only way to kind of gently remove it. And I don't know if you can see here. You see there are the two residues there. Those are the two contacts. That's what's missing there is the plating. And it's okay. Well, this battery is a mess, but okay. If you just consider doing two welds like that on the batteries, I think that's enough. With 5, you can, as I said, crank it up to 7, and you will perforate them. So I mean, for what I see, for the uses and the kind of the strength of the weld, it's fine. As I said, if you just pull it like this, you will rip it. Okay, here I've opened it up. And if you, I don't know if you can see. Well, there's a little hole. Okay, well, anyhow, as before. These are the 0.12, which are the ones that are, let's say, most used. This is the typical 8mm width 0.12. 0.12 nickel strip. 0.15 will also do. You can crank it up a little bit. In this case, as I said, I have shortened it, so keep that in mind. But always start with a And don't go above the 5 millisecond setting because you don't know how it's going to behave. Remember that on these versions, the resistor mod is highly suggested. Put a 470, 500 or maximum 560 ohms on that R4 on the MCU board. I keep saying that because I don't know if people are watching this or others. If you haven't, and this is the first one, probably go and check out the other one so you get more complete picture of the whole problematic on this specific BL18 or BL11, but this is, I don't think the BL11 is in production anymore. It was, I got one of the first and then they changed it quickly. They did the BL18 and then the I think BH, something like that, and BL01. People write B101, but it's actually BL. There are 2 letters and 2 numbers, which are the revision. The lower the letter, it starts from K, and then there was an H1, which it was even before, and then there was a J, which is the Maple Mini, which is a different one. It has 4 FETs instead of 5. This one comes with 5. And yeah, so basically I will maybe set up I set up a little table here. Let me see if I can bring it up on the PC. Let's see. Okay, just to show the various revisions. Okay. So BL19 and BL15 were the first boards which I haven't seen, but the BL19 definitely needs that cap mod. Okay, that has the driver on the MCU. But the ones that are now around are the BL11, BL18, and BL01. They just need the resistor mod and just maybe check the components if they're fluxed well, and that's all. Then the one that I had, also the it was BJ07, which is the one labeled smaller with the 4 MOSFETs, called Wise Maple. It seems okay. You don't need to do any mods because the whole thing is driven with 3.3 volts, and they removed completely the 1K resistor. It just drives directly the push-pull. Okay, so this is the quick comparison. I'll put this also in the description so you can reference it. So again, that's I just did this follow-up for these questions about these strips. So you can see that this was a 0.15. I actually did a test with a 0.30, but okay, of course this is way too much. But 0.10 to 0.15, it's okay. This thing is, they suggest 0.12 max, but actually you can use also 0.15 if you have a good battery like this. So that's it.